Hello, it's Mrs. Z. Mrs. Z. Okay, today we're talking about lesson 15, and it's a grade 5, mission 6, exit ticket, lesson 15. Um, it says draw a segment perpendicular to each given segment. Show your thinking by using sketching triangles as needed. Okay, so there is several ways. If you think about making perpendicular line to this one, it could be anywhere. If you take any straight um, any rectangle or a square, they have a 90 degrees angle, so you can place parallel to that line and just draw the rest. This straight line is perpendicular to this line segment. I can do that here as well, so anywhere it will create a right angle, so that side and this line is going to be a right angle, 90 degrees angle. But we, by using sketching triangles, we can prove. So if we draw that line this way, we can prove that how that happens, that it to be 90 degrees. So by knowing that we can, if I take and draw a line, let's see, if I draw a line like from this point right here, and I just draw this line, okay, and I'm thinking about this line with the line segment. It's a line segment is cutting the 980 degrees angle, which we call straight angle. So you can see right here from this point, it's a zero. Okay, this is zero line, and then you can go all the way to other side, and that is 180 degrees. So when you look from here all the way to here, that's 180 degrees. So what that tells you, that all these angles, this one here and that one, they need to add up to 180 degrees. But we need a straight angle. We need to have a three angles that are making. So if I think that way, then I need additional line here perpendicular to this line segment, so it will make me that. So now by knowing that, I can just think about and measure this angle right here. So by the rules, that is, I can see if I'm not starting with 80, 180, I go to 0 and all the way. So from this is the center of the circle. It goes, the angles live in a circle. So 10, 20, 30, 40 degrees. So right now I know that this angle is 40 degrees. Um, I can create this right away, like I can make that half of a circle, and I already know this has to be 40 degrees. When I create a right triangle, which is if I do perpendicular here, that means I'm connecting this side to the edge of that line. I'm creating a right triangle. So right now I can tell you that this is right angle, this is 40 degrees angle, so the other one has to add up to 90 in order to all three needs to be 180 degrees. So if this is 90, these two needs to be 90, so definitely this is 50. I can measure this angle if I want it, and I can prove it this time right now. So it's right here. You can see if this is zero line, you can go from 0, 10, 20, 30, 40, 50. The line segment line is at 50, so this angle is 50 degrees. So by knowing that, I can say, okay, if this is 40, I need a 90, and then how much more? And I will have 180 degrees. So because I'm creating congruent triangles on the other side, I'm going to do also 3 by 3. So that will give me, actually this one has to be 50, so I'm going to measure, has to be opposite, because when I flip, so if I look this right there, and this is a 0, I need actually this to be a 50. 0 line, 10, 20, 30, 40, 50. So here is the line that shows me the 50. If I look through here all the way, so this is going to be our perpendicular line that will give us, so I'm going to do, connect this line with um, my dot. Here's the dot right there, and then connect it to, it has to be the perpendicular line to this line segment. I can check, and it has to fit perfectly right there. So this is proof that if I have 50 degrees triangle, this will be just the opposite, like a rotate and create this triangle that will be 3, and this one would be the longest side right there. So okay, 3, 1, 2, 4, and here is a right angle. So this has to be 40 degrees angle. So 40 plus 90 plus 50 makes 180, the same as this one here, 50, 40, and 90. But then also when you look intersection of these, that's 40, this 50, that's 90. So this one is also 90 degrees, or we can just do the line like this. So that creates a 90 degrees angle. I can just do this. Okay, usually we don't put 90, but we know like this is 90 degrees. We don't label 90, we just do the little square right here. And by knowing that this is the right angle. So, and this line is perpendicular line segment that is perpendicular to our given line segment. Okay, that's A. Okay, and now we can do B. It's the same thing. The idea is to, wherever you on end point, you can do here or here. It doesn't matter where you start, but this is one of the point. It's the center of a circle. So if you like, you can draw the line, and then by knowing one line segment and the straight line, this will give us an angle that we can measure. So by knowing that, we can measure. So now I'm going to create my, I'm going to do my protractor different way. I'm looking for a 0. This is the center of a circle. So 0 line is right here. and I'm going to go from 0 to 10, 20, 30. So on my straight line with line segment will create 30 degrees angle. So now I know if I take the same, let's see if this is that. I can create and say this is 30 degrees angle. So now I need 30 plus what will give 90. So I know that 30 and 60 will give a 90, and then in between is going to be that right angle. So right now you can see if this is a rectangle and has a right angle, this is going to be that line that is perpendicular to this line segment. But to be precise, we know then this angle has to be 60 degrees. So we will go and measure it. So again, put your circle, center of the circle, and zero line is right here. Now zero line is outside. So 0, 10, 20, 30, 40, 50, 60. So if I put that right there where the 60 is, I know if I connect these two, that will be exactly perpendicular line. I can prove it to you by just putting my paper right there. So don't you see that how this is that creates a right angle in between these two angles. So right now I'm taking any straight edge and connect. So I'm going to go, and this is 60 degrees angle. So right now I can see where this comes, and also I can prove it by creating this right triangle. So here is right angle that creates right triangle. So here is right angle, here is 60. So this angle, this has to be 30 degrees. So 60 plus 30 is 90, 90 plus 90 is 180. So this one is also 90 degrees. So 90 plus 30 plus 60 makes all 180 degrees. Let's see now if this is 30 degrees, and I can also make this right triangle. So this has to be right angle. So this angle has to be 60 degrees because they are similar triangle with the same angles. So I can prove it to you. So if I look, and this is my zero line, and I go all the way 10, 20, 30, 40, 50, 60 would be from here to here. So that's how you prove that this line is perpendicular to the line segment that is given by using the right triangles and angles that together create a straight angle. Okay. So what this, if you don't understand that, is if I take right triangle and I cut this angle and the right angle, they all gonna give me a 360 degrees. So what that means is then if I take from this triangle 30 degrees, and then from other triangle I take 60 degrees, so then 60 and 30 makes 90, but then I also missing 90 degrees or right angle, so that will make all it will create a straight angle. Okay, that was B. Okay, let's do C. C again, I start by doing the straight line. Let's see if I make that straight line like this. So I can do right away if you want. I usually don't do the triangle right away, but if you like, I can create a right triangle right here. So I know then this is right angle, and I will measure one of those. So I'm going to measure this angle from the center right there. So if I go and measure it, it would be about, this is a zero line, like there, 0. And if I go to 10, 20, it's in between 20 and 30. So it has to be at 25 degrees. So now this one is 25 degrees. So if this one is 25 and this one is 90, this one has to be 65 because 65 and 25 makes 90 plus 90. All three angles in this triangles are going to be 180. So this would be 65 degrees. Okay. So now I need the perpendicular, and I know I can tell you that perpendicular to this could be like just like that. This is going to be perpendicular line, and that makes 90 degrees. But because I know it has to do something with the similar right triangles, so I can say that if I rotate this triangle and I create a new triangle here that has 65 degrees angle right here. So it would be adding 25, 90, and 65, and that will make 180 degrees. So our angle has to be 65 degrees. So I'm going to go and make the center. I'm looking for the 0 line. 0 is right there. And I'm going 10, 20, 30, 40, 50, 60, but I don't want a 60. I need a 65. So I'm going to put that right here. And that is going to create right triangle to this one. Okay, here we go. If I do that, that will make, hold on, it's about there. Okay, 65. And I'm like so now when I do this, I can see that this, all right. So I'm going to connect. So this is that triangle, right triangle that I can create. So I know this angle. I can also I can make this like that. So it's going to be 25 degrees, 65 degrees, and then 90 degrees right here. So all together I can make it nice. So that is 180 degrees. Of course, if this is 65 and this is 90, similar triangle like this one would be, other side would be 25 degrees. I can prove to you that there's some congruent angles, and you can see if this is a 0 line, 10, 20, it's not 30, it's in between 20 and 30, so it is 25 degrees. This is 25 degrees. Usually you label angles with the 2 arrows on both sides, so if you're gonna go precision, you can do this way. And then, but since they're really small, it's kind of hard. So if you have this line, that is line segment, this is perpendicular line segment to this, to that given line, right? So the last one is D. If I, this time I can, let's see if I do like, line like this. So I'm gonna start with this right angle because I can see that the line segment with this is creating right triangle. So I know this is 90 degrees, and then I can measure this angle here, and that will help me to find what other one would be. So if this one, I can also see, then I can create here right angle, or even this, depend on the angle. So this is right. Okay, so starting with the 0, and you go all the way to 0, 10, 20, 30, 40, 50, 60, 70. So you can see that it's in between this line segment is in between 70 and 80. So it has to be 75 degrees. So this right here is a 75 degrees. So I can, let's see if I can create, it's going to be, you know what, I'm going to just do the smaller triangle, smaller circle like this, right? This is 75 degrees. And then if this is 75, add up to this is 15 degrees. So this one has to be 15 because 5 plus 5 is 10, and 10 plus 70 is 80, plus 10 is 90. So these two, 90 plus 90, 180. So now I know that if I rotate this triangle, this angle here has to be that 15 degrees. So I'm going to create just a 15 degrees angle. So let me see, that's 10, and 15 is right here, right? So 15, I can see a line for 15 right here. So it should be that correct. So I can check, look, if I take my right angle as a paper, you can see that is the line that it has to go through. So I can create, so this is congruent. 1, 2, 3, 4. That's similar triangle. So here is a right angle. This is 15 degrees. Okay, I'm going to just like label outside 15 degrees. And then this is 75 degrees. Okay, so, and then this is 90 degrees. So right here is, we just created a perpendicular line segment that is perpendicular to the given segment. So here is this one. So that creates a right angle here. So 15 plus 75 is a 90, and plus 90 makes 180 degrees, which is a full straight line. So that's one way to do these using rules of the right triangles. But I also know when I went to school, we were doing right perpendicular lines or segment with this tool, compass. Okay, so I'm going to show you how that is done. So I'm just gonna, let's see how that looks like. All right. Okay, so next, make a larger, okay. So let's see if I have any line. If I make that line like here, let's do click 4 centimeters. Right, so that's just the line segment. So they say create the perpendicular line or line segment that goes through that in this one. So how would you do is you're gonna measure with the compass how long is that line segment. So how you're going to do it is just you create, and that is how long is that line segment. So I'm going to make a semi arc to the somewhere in above the middle of that side, and then I'm going to do also semi arc or semicircle on this side. Then I'm going to switch around. Now my pointer is there, and then I check, is the measurement correct? Yes. And then I'm going to make a new arc that intersects the other arc, and then also this one. So I usually use like 2 fingers to do it, but it's you can see now you have 2 points. You have a midpoint above this line segment and midpoint below that line segment. When I connect those 2 midpoints above, then I will create perpendicular line segment to that, giving so if you don't believe me, here we go. So there it is 90 degrees, and when you cut line segment into perpendicularly, you got yourself 4 90 degrees angles. So you got 4 90 degrees, so you practically go hold a circle. So that's 90 degrees. You don't label, but then this is also 90 degrees. This is 90 degrees, and this is 90 degrees. So the whole angles will make 360 degrees, which is any quadrilateral have 360 degrees. So that's that's how we used to do perpendicular line with tool compass. All right. So also maybe we can use and label. So like we can label this point to be A, and this point to be B. So this could be a C, and this could be a D. So now I have labeled the line segment, so I can say and use the tool. So if this is AB line segment, and we use the symbol upside down T like this, that is perpendicular symbol. So AB line segment is perpendicular to CD line segment. or vice versa, CD line segment. So it doesn't matter which way you start. You can say CD line segment is perpendicular to a B line segment. But the idea is, so if we do one more time very quickly to show you. Let's see if I have this line segment that it's right here. All right, so I'm gonna do this one. Okay, so it goes from here to here. So I need to find a perpendicular line to it. I'm using my compass, and I am measuring how long is that line. It's about there. So now I'm making arc below line and above the line. Then I'm gonna switch sides, and I'm gonna make again arc that will intersect the previous arc, and I got myself points that are perpendicular. They will create, when I connect them, they will create perpendicular line segment to the given line segment. So looks like I'm losing. Yes. So this line segment is perpendicular to it, and we can check. Here's your right angle paper, and that is labeled like this. All right. I hope that it makes sense what I was trying to teach you, and see you next time. Let me see what I did. Make all that smaller. Oh, that's it. Have a great day. Bye.